Hello and welcome back to Python Fundamentals. We were discussing about the operators in Python. So the next category of operators is bitwise operators. So the name itself implies that these operators perform bitwise operations. That is, these operators operate on operands bit by bit. So if we are giving input as an integer need to be converted to binary number and then the operations takes place. So the bitwise operators are categorized into, again, we have different types of bitwise operators: and, or, exclusive or, ones complement, right shift and left shift. So let us learn one by one. The first one is called AND operator. So as I told you, if you take a variable x and give an integer value and perform the bitwise operations, then the integer will be converted to binary and then the operations will be performed. So directly we'll give the binary numbers and check these bitwise operators. So to give binary numbers in Python, we have to assign values. X is equal to 0. B represents binary number. Now you know what is a binary number, consisting of zeros and ones. So you can take any binary number, a 4-digit binary number, suppose 1101. Now I'll take another binary number, y is equal to binary number of 1110. Now the first operator is AND operator. So, you know, it is a logical AND, similar to a logical and it returns 1 if both bits are 1. So, in this case of x and y, if you see here the x value is 1 and y bit is also 1. Here the x is 1 and y is 1. So, in these two cases, the AND operation must return 1 in the output, and the rest of the two cases, it will return 0. So let us look at the numbers. Yeah. Now, x and operator is and y. Now, if you use the operator directly on x and y, it will return an integer. So if you want to get the result in the binary format itself, we can use the function called bin function. So bin of x and y, then it will return the result in the binary format. So you can check here, 1 and 0 is 0, 0 and 1 is 1, 1 and 1 is 1, 1 and 1 is 1. So AND operator returns 1 if both the bits are 1. Now, the next operator will take the same variables. The next operator, bitwise operator, is OR. And you know what is logical OR? Logical OR returns 1 if either of the bit is 1. So we'll see, and both inputs are 1. So bin of binary of x or y. This is a symbol for the OR operation. So according to the OR, if any one of the bit is 1, or if both bits are 1, then the output should be 1. We'll take 0, 0 also, so that we can see all the 4 types. So here it is 1, 0. So the output must contain 1, 0 or 1 is 1, 0 or 0 is 0, 1 or 1 is 1. So let us check the result. Right. So 1 or 1 is 1, 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1. So we can write the OR operator returns, will take 0, 0 if both bits are 0. So it is easy to remember, right? Both bits are 0. So that is logic bitwise operator OR. Next operator is exclusive OR. You know what is logical exclusive OR? Exclusive OR is 1 exclusive 0 is 1, 0 exclusive 1 is 1. But if both inputs are same, like 1 and 1 exclusive OR 1 is 0, 0 exclusive OR 0 is 0. So we'll look at this binary O X exclusive operator is Y. This is exclusive operator. And then, so we have taken 1, 0. So 1 exclusive 0 is 1, 0 exclusive or 1 is 1, 0 exclusive 0 is 0, 1 exclusive 1 is 0. So it returns 1 or it returns 0, right? It is if both bits are same. This is easy to understand, right? So if both bits are same, so here we have both bits as 1 and here we have both bits as 0. So in these two cases, it has written 0. In the other two cases, it must return 1. So here, see, we have 1 exclusive 0, 1, 0 exclusive 1 is 1. Because here there are two zeros and hence it has discarded and has written only 1 once. So there is no meaning in giving the output zeros to the leftmost. So it has written 1 as the output. So this is by using the binary numbers. We can also use integers and simply write x is 3, y is equal to 4, then same x and y. It will return an integer equivalent, right? 0. So 3 and y, 3 and 4 is 0. So 3 is nothing but, we know that what is 3 in the binary format? 0, 1, 1. We'll write in the 4 digits, 0, 1, 1. And then 1 is 0, 1, 0, 0. So we know that this is 2 power 0's place, 2 power 1's place, 2 square and 2 power 4. Now AND operation. So if you write AND operation, what is AND? 1 and 0 is 0, 1 and 0 is 0, 0 and 1 is 0, 0 and 1, 0 is 0. So we have written that the x and y returns 1 if both inputs are 1. Here in this case, because all the inputs are different, so hence we got x and y as 0. So this is another way of performing the bitwise operations by giving integer values. We can directly perform on the binary numbers by assigning binary values by using 0b. So we have seen 3 types of bitwise operators until now, that is AND, OR, exclusive OR. Now we have another 3 more operators, one's complement, right and left shift. Now suppose I take x is equal to 3. Now we have complement of a 3, which finds one's complement of 3. We have to write as complement of x. What this does is it simply gives the value of minus x minus 1. So let us check this x. We can go for in the integer format or the binary format, minus 4. So minus 3 minus 1. It gives the complement of x will give you as minus x minus 1. So minus 3 minus 1, that is minus 4. We can also consider it in the integer. We can convert into binary value by using bin, and we can also check the complement operation. Next operator is called right shift. And suppose you take x is equal to 2, or we'll take the binary number 1, 1, 1, 1. 4 ones I'm taking. Now, shift. So the output I want in the binary itself. So the syntax is X. This is the operator for right shifting, and to specified values, how many values the right shift must take place? By 2 values. So right shift operator shifts bits to right to specified number of places. When it shifts to right, what happens? Let us see here. So when it is shifting to the right, so these ones will be replaced with these ones, and these 2 ones will be discarded. Suppose if we take an 8-bit number, also we'll take an 8-bit and again check the right shift operation. Suppose this is a 4-digit binary number. So if you take 00 and 11, right? Now let us check the shifting operation. Here also you can see that it has discarded all these values because the zeros have no meaning, and then the 2 bits will be shifted out, and then only the binary ones will be remained. We'll take one more example. I'll just explain with one more example. So for the right shift operation, it shifts bits to the right and discards them, right? So here instead of 000, 1 1 1 1. So here we have 8 ones and we are shifting 2 bits to the right. So if you see here there are 8 ones here, and if you see here we have 1 2 3 4 5 6. That means 2 bits of X are shifted out. So in the right shift operation, the 2 bits which are shifted to the right will be discarded. So let us see the next operator, that is called left shift operation. So left shift, the symbol is less than. So same thing, I am taking this left shift operator, and by the specified number of places is again I'm taking as 2. So in the left shifting, these 2 ones should be shifted left, and let us see what happens in the left shifting process. So in the left shifting process, what happened is the 4 bits are shifted to the left and 2 zeros are added to the number. In the right shift, the 2 bits in the LSBs, they are shifted out, whereas in this case, the zeros are added when we shift by 2, left shift by 2 values. Suppose if you take the same thing and check for the suppose if I write left shift by 1, then what? Let us see what it does. So see, if you see here, the 4 bits are shifted to the left and 0 is added at the place. So that is what left shifting operator do in the Python. And in the right shift, the values will be which are shifted to the right will be discarded, and here the zeros will be added if we shift left by specified number of places. If we specify by 1, so 1 0 is added. And if you specify, suppose if you specify as 3, 3 zeros will be added to. That means they are shifted left by 4 and the voids are filled with the zeros. That is called left shift operation. So the bitwise operators, as I told you, they perform operations bit by bit, and the operators are AND, OR, exclusive OR, ones complement, right shift, and left shift. And is, as you all know, what is AND in the logical AND is similar to here also AND. So it returns 1 if both bits are 1, otherwise it will return 0. And we can assign the binary numbers to the variables by using the syntax called 0b, so which tells that this number 1101 is a binary number. So this is a format how to assign binary values to the variables. So I have taken 2 binary variables x and y variables and assigned the binary numbers by using the binary format. And this is the operator for AND operation. So when we write x and y, then it will return the value in the form of an integer. But if you want to see it in the binary format, we can use the function called bin. So bin of X and Y, then the output will be in the binary format. So AND operation returns 1 if both bits are 1. The next operator is OR. This is a symbol for OR, bitwise OR. And you all know that the OR operation returns 0 if both bits are 0, else it returns 1. So again, I have taken the same example and performed the OR operation. The next operator is called exclusive OR, and this is a symbol for the exclusive OR. And exclusive OR, you all know that it returns 0 if both bits are same. That is, if there are 0, 0, output is 0, 1, 1, output is 0. If it's 0, 1, it is 1, 1, 0, it is 1. So we have checked for the these two binary numbers, 1, 0, 0, 1 and 1, 0, 1, 0. And the next operator is the complement operator. The complement operator, what it does is, it finds when x is a new integer value to x, so it finds the minus of, it returns minus x minus 1 value. So this is a symbol for the complement. So I have taken x is equal to 3 and have found the complement of x. Similarly, you can take a binary value and find the complement of x, but it will return the same value. So in the binary format. The next value is the right shift operator. Right shift operator, when we use it, this is a symbol for the right shift operator. And when we are using, this is the syntax. So x is the binary number. This is the right shift operator. To how many places you have to shift the number, that you have to specify. And here I specified as 2. So x right shift by 2 places, then it will shift the 2 numbers to the, it will move out the right to shifts the number to the rightmost, and then it doesn't fill with the zeros, but it will remove this LSBs by the specified number of places. If you specify as 3, then all the 3 ones will be, only MSB is left. So similarly, we have the left shift operation, which shifts the number to the left and fills the voids with the zeros. That is not what happening with the right shifter. It's just discarding those shifted bits, but here it adds the zeros and it moves the bits and adds zeros at the end. That is called left shift operation. So these are the bitwise operators in Python. I hope you understood the bitwise operator. Thank you. We'll meet again in the next video.